All right, here's section 1 of our chapter 3, and in this section we're really going to be looking at some linear functions and how we can graph and build them. Okay, so here's our learning targets. First, we're going to graph linear functions. Then we're going to use some average rate of change to identify if we're talking about a linear function or if we're not. Then we're going to look at whether we're increasing, decreasing, or constant. Then we're going to take some verbal models, some word problems, and turn them into linear equations. Okay, so we've seen this before. A linear function is f of x equals mx plus b, where m is my slope, which is the steepness of my line, and b is that y-intercept, is where it crosses the y-axis. So when we're graphing a linear function, we generally want to start with my y-intercept first and graph that point, and then we can look at the slope. So for this one, I would start at 7, because that's my y-intercept, and my slope is a -3. So I go down 3 and over 1, and down 3 and over 1. And then I can draw my line through that. Okay. So now I'm asked what are the domain and range of f. So when I'm dealing with linear functions, the domain, and when I'm dealing with any functions, the domain is my x values, and my range is my y values. So here I see with this linear function that my domain continues on in both directions, so that would be all real numbers. And my range also continues in both directions, so that range is also all real numbers. So here's again another picture that we've seen here. So I start at my y-intercept, and I go with my slope. I go down 3 over 1, down 3 over 1, and I connect those dots. I also see that my domain and range are all real numbers. So now we're going to look at some average rate of change. So to find the average rate of change, I can make a table of values. So we're using the same function that we just used in the last example to find the average rate of change. You've also seen average rate of change being slope, and we'll talk about that in just a second. But this is the same thing as our slope. So the change in y over the change in x. So here if I plug in these x values into my equation, I will get these y values. So now I can find my slope. So I see here my change in y, my change in x is I go up 1 and I go down 3. So I go down 3 and I go up 1. So my slope, or my average rate of change, is that -3. So then I look between these 2 points, and it's also -3. And between these 2 points, it's also -3. So since my average rate of change is the same for all of them, then I know that yes, this is a linear function. That's how we can use average rate of change to help us determine if we're looking at a linear function or just any other kind of function. Okay, so again, here's what I said, that our average rate of change, that delta y over delta x, is the same thing as our slope, rise over run. And we've looked at that many times before. Okay, so here we're going to actually use that average rate of change to identify if it's a linear function or not. So I have a strain of E. coli that's placed into a petri dish and is allowed to grow. So we're going to look at some data that's collected from that. So my population is measured in grams and the time in hours. It's always important to keep an eye on what we're measuring and how we're measuring it. So plot them and use the average rate of change to determine if this is linear. So here's my data. Right, so I've got my number of hours elapsed and my population. And here they've gone ahead and written it into XY format for us. So we can graph those. Here's our graph for that, right? So my time in hours and my population in grams. And just looking at this, I can see that it's not quite linear because I'm starting to have this curve to it. And I know that if I have a curve, it's not exactly linear. Okay, so, but I can also look at my data table, which is what we're talking about here. So it's not the same. So let's go back to our actual data table here. Okay, so right here I see I go up 1. So here I go up 0.03. So if this is linear, I should also go up 1 here, but I should also go up 0.03 here, but I don't. So these two values are different. So let's see what happens again. So again, I go up 1 here, but here I go up a different amount, 0.06. So since these are not constant, this is not linear. Okay, and I always want to look at like 3 points to get my my head around what's exactly happening. Okay, so we can also say that it is not linear. So now I also have this next example. So this data that we're going to look at is the maximum number of heartbeats of a healthy individual during a 15-second interval of time. So first I want to plot it and use my average rate of change to determine if it's linear. So here's the data table, right? So I've got my age and my number of heartbeats. So again, I've got my table here. I can also graph it. Whoop, there's my graph. And so I see my graph looks fairly linear. But I also want to look at my average rate of change here. Okay, so I see I'm going up a constant amount, and I see that I'm also decreasing at a constant amount. Since all of these are the same, then I say yes, it is linear. It is a linear function, so I can use a line to estimate and to help me with this function. Okay, so now that we've determined whether these functions are linear, we're going to figure out if it's increasing, decreasing, or constant. Okay, so we know that it's increasing if my slope is positive. That would be an increase. If my slope is negative, I know it's going to be a decrease. And we'll look at if my slope is 0, right? If slope is 0, then I know that it's going to be constant. So let's look at some examples. So here is my first example. So my slope is always the thing with my x. So since this is a positive number, I know that we are increasing. Okay, so there's my final. It's increasing there. Here it's negative, so I'm decreasing. Positive, even though it's a fraction, it's still positive, so I'm increasing. And here my slope would be 0, because I could have 0x plus 7. So here it's going to be a constant slope. So my function would be considered constant there. And that's exactly what we said. And here, since we know that the domain and range of our lines, of our linear functions, is all real numbers, I can use interval notation and tell me that from negative infinity to positive infinity, I'm going to be increasing. My function will be increasing or decreasing or constant. So we want to keep that in mind as well. So now we're going to take those word problems and those verbal descriptions and build us some linear models. Okay, so again, we're going to live in y equals mx plus b, or this f of x, because we're really going to be dealing with functions. Okay, so book value is an asset that a company uses to create its balance sheet. Some companies depreciate assets using a straight line depreciation, so it decreases by a fixed amount each year. So the amount depends on the life that the company assigns to the asset. We'll see this in cars a lot. So here we're actually talking about cars. So suppose a company just purchased a fleet of new cars for its sales force at a cost of $31,500 per car. The company chooses to depreciate each vehicle using our straight line method over 7 years. So that each car depreciates $4,500 per year. So first we have to write a linear function that expresses that depreciation. Then we want to graph it, and then now that we have our expression and we have our graph, we can check and see, well, what's that going to be after 3 years? When will my value be $9,000? How can I interpret the slope? So let's look at a couple of these pieces. So I know that my depreciation, right, my price is decreasing. That's the thing I want to keep in mind, is since we're decreasing, I'm going to have a negative slope per year. Whenever you see the per or the each, that's the piece that goes with your variable. So I know it's decreasing at $4,500 per year, so that's where my variable goes. And here's my starting point. My y-intercept will always be my starting point. Okay, so here's my function. V of x equals a negative 4,500x plus 31,500. So then I can graph it. There's our graph. So I can just take each of the points and plug in different x values and plot them and then connect those points to find my book values. Okay, so now I was asked to find the value after 3 years. So I can either use my graph or I can just plug in 3 wherever x was, and I know that I can because x was years, right? And this was telling me 3 years. So I plug that in, I multiply here, and then I can add my 31,500. So I know that after 3 years, the car is worth $18,000. So then in part D, I was asked to analyze the slope. So when we're analyzing the slope, I want to use the words that go with my entire sentence and the actual problem we're working on. So here's my slope, right, is a negative 4,500. So that tells me that the car loses value of $4,500 per year. Okay, so that's how I would analyze it, using words from the equation and from my sentence here. So each year that passes, I decrease $4,500. That's the best way to analyze this information. Okay, so now the final thing I was asked was E, to find the book value when we're dealing with $9,000. So how many years, after how many years will it only be worth $9,000? Well, so I can plug that in for my V of x, and then I can solve for my x value. So first I have to subtract that 31,500 from both sides, and then divide both sides by 4,500. So then I end up with x equals 5. So after 5 years, my car will be worth $9,000. I could also use my graph to figure that out as well. So I could find where $9,000 is right here, because I know that's the money I'm working with, cross over to my graph and down. And this will tell me the age of that vehicle at that point in time. Okay. So we can also look at some supply and demand here. So the quantity supplied is the amount the product that the company makes. The demand is how much people want. So here we're going to talk about this company making some widgets. And here's their supply and demand. So supply is 40p minus 200. Demand is negative 20p plus 1,000. So P is going to be that price in dollars. Okay? So now I want to find the equilibrium price and the equilibrium quantity. So when we're looking at equilibrium, that means that the two things are equal to each other. Okay? So we're going to try and find the intersection of those 2 points. Okay, so here's what we're doing here. So to find the equilibrium price, I set them equal to each other. I get all of my p's to one side, all of my constant values to the other side, and I solve for my p. So my price is $20 per widget, and I remember that p was price, so I know that it's $20. Then the second part of A was asked, well, how much is that? So I can take that $20 and plug it into either the S or the D and solve, and I see that it is 600 widgets. So there will be no, and what this really means with supply and demand is that when that means that if they charge $20 per widget, the company makes 600 widgets and has no shortages or excess inventory. They're able to sell all of them. Okay. So we were also asked, when does my supply get greater than demand? Okay. So again, I can set these two using my inequality symbol and solve for my P as well. So if the company charges more than $20 per widget, they will have more supply than they need. Okay, so that's how they can look at that too. So we can also graph these. Since they're just lines, we want to graph them both. We can see where they reach equilibrium. That's where my points cross. That's where the two lines intersect each other. So I can also see that based on my graph as well. Okay, so now that we've gone through these, let's look at our learning targets real quick. Here we go. First, we were to graph linear functions, and when we're dealing with linear functions, we want to kind of live here. Start by graphing the y-intercept and then the slope. We looked at average rate of change to see if it was a linear function, and if so, we could then determine if we were increasing, decreasing, or constant. Then we took several different word problems and built our linear models from there. So now that we've worked on this, go ahead and work on your homework for this section.